All right, so last time we took a qualitative view of pH, right? We said acidic, basic, and then we identified some solutions that are that fit into the categories. Next up, we want to take a quantitative look at it, so the numbers. The first thing to realize, or that's important to realize about the pH scale, is that it's a logarithmic scale. And what that means is that small changes in numbers actually represent a big change in the characteristics of the solution. So for example, the Richter scale measures earthquakes, and that's also a logarithmic scale. So for example, something on like a level 4 is very small, right? It happens almost daily. And something like at a scale of 10 only happens every 1,000 years, and the movement is extreme, right? So that's only a difference of 6. So how do we get these numbers that aren't that different from one another to represent a large change? And that's through the use of a logarithmic scale. And we'll see what that means in a second. So pH is equal to the log of the concentration of the H3O plus or H plus. It means the same thing, right? H3O plus or H plus. It doesn't matter which one you use. These brackets right here indicate that we're talking about concentration. Right, so not the number of H pluses, but the concentration. And so then let's take a look at pH is equal to 5, and then pH is equal to 7. And we want to calculate what's the concentration of H plus. Well, we would take our equations, right? We would take these values and plug them in on the pH side. So for example, here you get 5 is equal to the negative log of the concentration of H plus. And over here you get 7 is equal to the negative log of the concentration of the H plus. And so now what we want to do is isolate the H plus. So we'd multiply both sides by -1 to move the negative over. Then we would have -5 is equal to log of H plus. And then over here, -7 is equal to the log of the H plus. And then we have to move the log to the other side. The way that you move the log to the other side is you raise both sides to the power of 10. So if you have a standard calculator, your log function is right over here, and the up to the 10 is right above it. You just have to click that second and then that log function. If you don't have a standard calculator, my recommendation is to get one. They're about $10 to $15 on Amazon. And this Texas Instrument one will last you forever. I still have one from, I think, either high school or middle school, right? And it still works, right? It's got this little cool solar disc right there. So you don't even have, I've never even changed the battery on mine. Really useful. I know a lot of people try to use the calculators on their phones. I would not recommend that. I don't think that's a good idea. Okay, so we raise both sides to the power of 10. When we do that, the logs cancel out. And on this side, we'll have 10 up to the -5 is equal to the concentration of H plus. And then up here, 10 to the -7 is equal to the log or to the concentration of the H plus, right? The logs canceled out. And then if we write that 10 to the -5 and 10 to the -7 as numerical values, it would be 0.00001 molar H plus. Note that there are 4 zeros there. And then over here, we're going to have 6 zeros. Again, you can just type that 10 up to the -7, 10 up to the -5 in your calculator. And so if we think about what's the difference in this one, first off, this is the larger number, right? It's got less zeros before that one. So this one has more H plus, which means that it's more acidic, and that makes sense, right? 5 is less than 7. And as we get lower and lower on the pH scale, we get more and more acidic. Now, what's the relationship between these two? How many times more acidic is it? Well, in order to get this number to equal the number to the left, you'd have to multiply it by 100. So it's 100 times more acidic. And that's what the logarithmic scale means. It means that every change in one number is 10 times more than the next one. So for example, if you have a pH is equal to 3 versus a pH is equal to 7, right? We can immediately tell this one's more acidic because it's the smaller number. And then how many more times acidic? We just have to subtract the numbers, 7 minus 3. That gets us to 4. And then that's the number of zeros that we add. So For example, we'll add 1 and then 1, 2, 3, 4 zeros. That's 10,000. So the pH of 3 is 10,000 times more acidic than the pH of 7. And so that's how you get these large changes in properties in such a small scale, right? Just kind of 1 through 14 for the most part, but they can have huge differences because they're logarithmic. Again, just do a couple practice problems and get familiar with this type of calculation.